Okay, we have here today another integral. This one's from the MIT Integration Bee 2025 quarterfinals, round 4, problem 3. We have the integral of 1 over x to the 8th minus x to the 6th dx. Okay, I did this one a bunch of different ways on paper, but they all start the same and they're all really similar. Just there's a lot of factoring that needs to happen. I think what we'll do to start is just do the obvious thing and factor x to the 6th out of this. You might be able to factor out x to the 8th. That's the way I do these a lot, but I don't know how it works here. It didn't seem like that was a good option. So what I did was factored it like this. And from here, we have a lot of options because it's set up where we could do partial fractions. That might be the most obvious thing. Although partial fractions, I found I did it out and it was pretty tedious with the 6th power here. So I don't really like it that way. I find that I made mistakes. I actually got it wrong because when I do out that many terms, I usually make a mistake. So I don't know. I kind of hate it that way. So let's look at something else. What I want to do instead, and I think a lot of the factoring methods will start with, we've got a 1 here in the numerator. And what I can do to create cancellation is I can add x to the 6th on here, just add it to the 1, but also so we don't change it, let's subtract off x to the 6th. And then let's go ahead and break it up into two integrals. For the first one, we'll use the x to the 6th because we're going to be able to cancel here with this x to the 6th in the denominator. So that one's going to be just a formula, so that's pretty nice. On this one, let me reverse the sign on it, because here we're 1 minus x to the 6th. If I bring a minus in front, then I can write this as x to the 6th minus 1 x squared minus 1 dx. And here's where a lot of different variations come from. Because for this, you could factor it as difference of two squares, right? I could factor it x cubed plus 1, x cubed minus 1. I'd need to factor it more because we would need to factor this and try to get cancellation. So that's one way. Another way, for anything, it doesn't matter what the power is. I think it needs to be an integer, right? But anything, if you have x to the n minus 1, you can always factor this as x minus 1, and then you have a bunch of terms here. I think it's just all the terms added all the way down to 1. Also, when you have an even power, you know that minus 1 is going to be a root, because you plug in minus 1 with an even power, you're going to get a 0. So you can factor it also when n is even. You can, I don't know why I did that, but you can factor an x plus 1 out. The rest of it's going to be similar to all the terms, but it's going to be alternating signs. So you have something like xn minus 1 minus xn minus 2, etc., all the way down to minus 1. So lots of options with the algebra, but instead of all that, what I want to do is, for x to the 6th, I can write it as x squared cubed minus 1, or minus 1 cubed, and then we can use difference of cubed formula, difference of two cubes formula, so we can write it as x squared minus 1, then it's going to be x to the 4th plus x squared plus 1. And now this whole thing is over x squared minus 1, and I did make a mistake, right? Because I forgot we have to have x to the 6th here. So we have x to the 6th on that, x to the 6th here, but then I can cancel this with this, divide the x to the 6th into the numerator, and what we have for this whole expression is going to be just x minus 2 plus x minus 4 plus x minus 6. So let's take this thing and we'll plug that back into the second integral. When we do that, let's clean up this here because we're going to have x to the 6th are going to cancel on this. Integrating 1 over x squared minus 1, really common integral. We can do this with a formula. You could do it out like you could do quick partial fractions, cover out method. There's a bunch of different ways, but I'm going to just do it as inverse tanh of x. If you did it out with the partial fractions, you'll get it in terms of natural log. You'll have something like this here. I think you're going to have absolute values, so you'd have that. Same, you can do this with a formula as well and get to the log version. Then for the rest of this, we need to integrate all this. So we have the integral of x minus 2 plus x minus 4 plus x minus 6, but this is all going to be just power rule. So we'll bring down this first part and then we'll go ahead and integrate. So we have our minus inverse tanh of x. Here, this is going to become, everything's got a minus, so it's going to reverse the minus here, so it's going to be positive 1 over x. And here, this is going to be positive 1 over 3 x cubed, and this one's going to be positive 1 over 5x to the 5th. add a plus c on the end, and that's it. Okay, so I think with everything I mentioned, I think that was 5 methods. Not really methods, just like variations on factoring. So maybe just variations because they're very similar. I think also on here we have, I think for another thing I said finite geometric series. This is like this part here to the right is like a geometric series. Although that's just going to be like some of the factoring. Also, what was the other one? Oh, also you can kind of do partial fractions on the fly, expanding this out. I think I'm going to do another video on that, even though I don't really like it as much, but just for fun, we'll do it. So anyway, there you go. That's it for today. Thanks everyone for watching. Have a good day.